Okay, here's part 2 of homework 8.6 on vectors. This is the same sheet we did with part 1, but now I'm going to add the questions at the bottom. And all that is, you'll see, is just another example of what I did pretty intensively here with other examples. So question number 1 starts fresh and gives us component form and says find or graph the vector 2, comma, negative 5. Okay, that's simple enough. Just remember that is just like on the coordinate plane. We're going to start at the origin or the middle, and we're going to go over 2. Negative 5 is down. 1, 2, 3, 4, 5. So this vector, it'd be very easy to graph, easy points. Oops, if I can draw straight. That's too bad. Nice straight line. You can use your ruler, OCD people. So there's our vector. Again, down 5 over 2. Okay, number 1, check. Sorry, it wasn't harder. Question number 2 asks us, we'll now find the magnitude of this. And if you remember, that's simply the length. So how powerful is that magnitude, or what is its speed? And so it just helps to remember that we're going to use Pythagorean theorem. And I'm going to just write the numbers in here. This is 5. This is 2. So to calculate that, we simply do a squared plus b squared equals c squared. And so that's just going to be 5 squared plus 2 squared equals c squared. 25 plus 4 equals c squared. Add those together. 29 equals c squared. Okay, and then the square root of both sides. And that tells me that c, or the magnitude, is, and that I calculated that, it's approximately 5.4. 5.4. So we learned this way back at the beginning of the year in chapter 1, Pythagorean theorem. And you just recognizing what component form represents. And so this has a speed or a magnitude of 5.4. In a word problem, we could give units to that so that we could actually say how fast that thing's moving or whatever it is. Okay, then question 3 is doing the other vital thing with a vector, and that is giving its direction. Okay, giving its direction. And so we can go ahead and put that in. Look at this right here. Now again, direction can be given from both the horizontal or the vertical axis. So I could do this either way. I could create the triangle here and calculate it from here. Since I already had drawn these lines here, I'm just going to use this angle as my theta. So it's going to always be tangent, so katoa, because from this angle, that's opposite and adjacent. There's no hypotenuse. Always important, though, to be clear on which triangle you're using, because that will change your answer. So tangent of our unknown angle, I use Pokeball theta, equals opposite 2 over adjacent 5. And again, this is a super quick calculation. We just inverse tangent both sides. That's what I mean by if you're not confused by the definitions of what you're trying to do, the calculations for this chapter are not difficult. So now we just go ahead, inverse tangent, 2 divided by 5, 21.8 degrees. We'll go ahead and say 22 degrees. All right, so theta is 22 degrees. And now we got to give the direction. So I started, because I put it here, I'm starting south. So south, 22 degrees, and I'm moving, or it's angling to the east by 22 degrees. So south, 22 degrees east would be a very good direction. If, for example, I had chosen this one here, what you can see is I would have had a slightly different. My opposite would have been 5, and my adjacent would have been 2, and I actually would have gotten the complement of this. I would have gotten, 68 degrees, and I would have gotten 68 degrees, and it would be 68 degrees or east, 68 degrees south. And so that would be that's also correct. So there are in a way 2 possible answers depending on how you draw, which line, whether the vertical or the horizontal line you choose to measure this direction. Either one is acceptable. So just keep in mind, this is the same. This is equivalent to as what I just said. If I started east, 68 degrees south, if I had done it the other way. So if you got that answer, you're still correct. Okay, we're almost done. Number 4. And so, yeah, we already reviewed how to give that answer as asked in the question. Start with the axis you started with, south, and then I moved to the east with my 22 degrees. All right, number 4. Here we go. We haven't covered this yet, but that's because it is so incredibly difficult. No, actually incredibly easy. How do you add vectors? How do you add vectors? Almost in your sleep. Let me just give you an example, and you can make up your own, or you can just copy me, which is why I make these videos, trying to make your life easier. Let's say I have my vector 2, -5, 2, -5, and I have to add, oh no, vector, and I'm going to make one up. Let's just say 3, 4. 3, 4. What on earth will I ever do? Well, watch this amazing magic trick. The resulting vector would be 5, -1. Did you catch that? Can you see what happened there? 5. How did I get 5, -1? You just add the x's. Add the two x's. 2 plus 3 is 5. Add the two y's. -5 plus 4 is -1. And so this is the resulting vector of adding these two together. Now what we just did was, I'll show you visually what we just did, but as far as just adding them and getting the answer, it's that easy. So don't hurt yourself adding vectors. Just, of course, make sure you add negatives correctly. 2 plus 3 is 5. -5 plus 4 is -1. Visually what happened is look, if we show the vector that we added, here's the one that we started with, 2, -5, and we had vector 3, 4, 1, 2, 3, 1, 2, 3, 4. That would be right here. And so what we just did is we added these two vectors together. And the one that we got as the answer was 5, 1, 2, 3, 4, 5, -1. And what I just wanted to show you about this is you have the correct added vector if the two that you added together form a parallelogram with the resultant. If I look at this, another way of looking at this is say I was at 2, -5 and I added 3, 4. Well, look, if I went up or over 3, 1, 2, 3, up 4, 1, 2, 3, 4, up, there's my vector. Or if I was here and I added 2, -5, over 2, down 1, 2, 3, 4, 5, yep, here I am. So these always form a parallelogram. The two that you're adding together always form, the resultant forms the fourth angle of a parallelogram. So if your three vectors don't look like this at the end, you did something wrong in adding them together. And if that's confusing, don't worry about it. Just remember how simple it was to find the 5, -1. Adding vectors is very simple. Okay, good luck. I'll make a video of a couple questions from the classwork, but you can do it and reach out if you need help.